In 2013, a physicist named Ruben Meerman lost 15 kilograms and then realized he had no idea where it had gone. Not in a vague way, he wanted to follow the actual atoms out of his body, and when he went looking for the answer, he discovered that almost nobody had one. So he surveyed 150 doctors, dietitians, and personal trainers, and more than half of them got it wrong. Then he did the calculation himself, and the answer was strange enough that the British Medical Journal published it. When you lose fat, you don't burn it away and you don't sweat it out. You breathe it out. 84% of it leaves through your lungs as invisible carbon dioxide, one exhale at a time. Meerman and Professor Andrew Brown showed the lungs are the single biggest exit your body has for fat, and yet the fat cells themselves never actually go anywhere. Hold on to that last part, because it's the reason losing weight is so much harder to keep than to lose. To understand any of it, you have to start with what fat physically is, because it's not what most people picture. A fat cell is basically a container built around a single droplet of oil. That droplet is made of molecules called triglycerides, which are just 3 chains of fatty acids tied to a small backbone. And when you eat more than your body needs, the excess gets packaged into those triglycerides and tucked into the droplet. The droplet grows, and the cell stretches around it like a balloon filling with water. It can swell to 50 times its resting size before your body decides it needs to build new cells to keep up. Here's the part almost nobody knows. After your mid-20s, the number of fat cells you have barely changes. When you gain weight, the existing cells get bigger, and when you lose weight, those same cells get smaller, but they don't die, and they don't leave. They just deflate and sit there, still fully intact, which matters more than it sounds like right now. So if the cells stay, what actually happens when you finally lose the weight? It starts with a shortage. When your body is burning more than you're feeding it, it has to pull energy from somewhere. Therefore, it reaches into those fat cells. A hormonal signal goes out, enzymes inside the cell switch on, and they start cutting the triglycerides apart, snipping the 3 fatty acid chains away from their backbone until one molecule becomes 4 loose pieces that drift out into your bloodstream. This is the exact moment people picture as burning fat. But nothing has actually been burned and nothing has left your body yet. The fat you think you're sweating off on a treadmill is, at that exact second, still inside you, just floating through your blood looking for somewhere to be used. All that's happened is that it changed address. Where it goes next is where the real answer lives. Those loose fatty acids travel to whatever tissue needs fuel, your muscles if you're moving, your liver if you're fasting, your heart almost constantly, and once inside those cells, they get broken down further and further into smaller fragments. Those fragments get fed into the process your body uses to make energy, and at the very end of that chain, the carbon atoms that used to be your body fat have nowhere left to go except to grab onto oxygen and become carbon dioxide. That carbon dioxide slips into your blood, rides to your lungs, and leaves on your next breath, invisibly, which is exactly why nobody ever notices it happening. Meerman and Brown ran the numbers on 10 kilograms of fat, and the arithmetic is genuinely hard to believe the first time you see it. Burning 10 kilograms of fat requires your body to pull in 29 kilograms of oxygen, and the whole reaction produces 28 kilograms of carbon dioxide and 11 kilograms of water. Out of the original 10 kilograms, 8.4 leave through your lungs as carbon dioxide, and the last 1.6 leave as water through your sweat, your urine, and your breath. That's not a metaphor. It's just the weight of the atoms, tracked from start to finish. When they asked those 150 professionals where the mass went, the most common answer was that fat turns into energy or heat, and that answer breaks basic physics. Mass can't quietly turn into energy, therefore it has to become something, and the something it becomes is a gas, leaving through the only organ you have that expels gas without stopping. There's a detail here that reframes every frustrating cardio session you've ever done. A full hour of running only bumps up the carbon you breathe out that day by around 20%, and a single large muffin puts all of it right back. The exit is your lungs, the entrance is your mouth, and the entrance is always faster. And this same journey, fatty acids leaving the cell and pouring into your bloodstream, is why one of the most stubborn beliefs in all of fitness is simply wrong. You cannot choose where you lose fat. When those fatty acids get released, they don't stay near the muscle that's working. They flood into your general circulation and get pulled from fat stores all over your body at once. Researchers have tested this for decades, and it keeps landing the same way. In one study, participants trained a single leg with thousands of leg presses while leaving the other leg completely untouched. And when they lost fat, both legs lost it evenly. The trained leg got no special treatment. A later review pooling 13 separate studies across more than 1,000 people found the same thing every time, that working a body part builds the muscle underneath, but does nothing to shift the fat sitting on top of it. The reason some areas cling on while others melt away isn't effort, it's plumbing. Certain fat deposits, like the belly and the thighs, have more of a specific receptor that blocks fat release and weaker blood flow to carry it away, so they empty last no matter what you do. Your body drains its fat like one shared tank, not like separate compartments you can open one at a time. If your model of your own body just shifted a little, that's exactly what this channel is for, so hit subscribe and the next one will change how you see something else you thought you understood. Which brings us back to those fat cells, the ones that shrank but never left. They didn't disappear, they deflated, and an empty fat cell is not a quiet, harmless thing. Research in the journal Nature found that fat cells hold on to a kind of memory after weight loss, keeping changes in how their genes behave that make them quicker to store fat again. And separate work from Yale found that fat cells can start forming within a single day of overeating. The system was built to store energy, so it never really stops being ready to store energy. Those shrunken cells aren't sitting there plotting against you. They're just waiting to do the exact job they exist to do, and they remember how to do it fast. So here's what actually happened to the 15 kilograms Ruben Meerman lost. Most of it left through his lungs, one ordinary breath at a time, scattered invisibly into the air around him, while he had no idea it was happening. The cells that used to hold it are still there, smaller and quieter, ready to fill back up the moment he gives them a reason to. That's where your fat goes. Not into heat, not into your sweat, but into thin air, and the containers it leaves behind never close for good. If you want the next thing your body is quietly doing without your permission, the video on screen breaks down exactly what happens to a muscle the moment you tear it. Watch that one next.